Hi everyone. Today's lesson is going to tackle the idea of graphing linear inequalities. Now we just got done actually taking a quiz on graphing linear equations, and we know the difference between an equation and an inequality is that an equation is going to have an equal sign, whereas the inequalities are going to be your less than, your greater than, less than or equal to, greater than or equal to. So it's going to be very, very similar with one little twist of lemon at the end of the problem. So we're just going to get right into it. You have an example packet that looks just like mine, and we're going to start in with example 1. So I need you to copy this down here at the bottom. Example 1, we are going to graph y is greater than or equal to 1/4 x minus 5. Okay, so this inequality you can see is in slope-intercept form. So it will be very easy to graph. One thing we can pick out is we can see right here that our slope is equal to 1/4, so that will help us with our rise and our run. And we can also see that our b, which is our y-intercept, is going to be located at, well, when you're finding a y-intercept, your x is 0. And you can see right here, when x is 0, this part goes away, and we are at -5. So we will come up to our graph, and we will launch off from 0, -5, which is down here on the y-axis. There's my b, my y-intercept. And from there, I will rise 1 and run 4. And I don't have enough room to go again, but I could go the opposite direction, down 1 and left 4. Okay, now I will draw my line. One little note here, and this we're going to do as we do all the examples. When you go to draw your line, you have a choice to make. And the choice comes right here when you look at your inequality symbol. If the inequality symbol has an equal to with it. See how this is greater than or equal to? So your solutions for y are both equal to the line as well as greater than the line or above the line. So when it has the equal to, you are going to make your line a solid line. So maybe off to the side, you want to write yourself a little note. If your symbol is greater than equal to or less than or equal to, either way, when it has the equal to, we are going to have solid. But if your symbol, and we'll see this in another example, does not have the equal to, it's just greater than or less than, then that will be dashed, and I'll show you what that looks like in a second. Okay, so back to our line. We are going to make a solid line. So I'm going to take my 3 dots that I drew and come through solid. Put my arrows on the ends to show we continue on, even though we're out of graphing room here. And now comes shading. This is the fun part. So your solutions to your equation are no longer just on this line. All of your y values that are solutions to this inequality lie greater than or equal to this line. So here's what you do. You're going to put your pencil on the y-intercept. So I want you to put your pencil right here on the b, or the -5, okay? And now I want you to ask yourself this question. If the y values are greater than this, would they go up? Here is the y-axis, right? Is upward getting y greater? Or should I go downward for y to be greater? So I hope you're thinking that the y's get greater this way. So I want you to point an arrow up. And you can point that arrow up coming off of all three of these points. So the end result, everybody, is that to graph this linear inequality, you're going to color or shade all of this area above this line. All of these ordered pairs up here are actually solutions to your linear inequality. I might even go over this with a highlighter just to kind of really show it. You can get creative here if you have colors in your backpack. Okay, now I won't do this on every example, but for this example, let's kind of analyze our result. So the idea is this, everybody. So if you wanted to, let me change colors here. If you wanted to like check your work, let me do a little check here. If you wanted to check your work, what you would do is you would pick a point that is in this area, okay, in this shaded area. So maybe I'll pick something really simple like the origin. I would say that the origin here, 0, 0, is in this area. So I'm going to do 0, 0. So 0 is my x and 0 is my y. Now I'm going to plug that point into my inequality statement. So moving from left to right, the y is 0. So 0 is greater than or equal to 1/4 times x, which is also 0, minus 5. And so if I finish that math, that's going to give me 0 is greater than or equal to this guy right here. 1/4 times 0 is 0 minus 5. So 0 is greater than or equal to -5. And you have to ask yourself, is that true or false? Well, 0 is greater than or equal to -5. So that's true. And what that tells me is I've got the correct side shaded. If I would check a point in this area down here, I bet it's going to be false. But we can test it. So a point down here might be something like, how about this guy right here? How about 0, -6? Let's test out this point. And I only choose that because I like to work with 0. It's easy to work with. So if my x is 0 and my y is -6, let's take a look. So putting it into my inequality, my check would be -6 for my y is greater than or equal to 1/4 times 0 minus 5. So again, I just filled in 0 for x and -6 for my y right here. And so that gives me -6 is greater than or equal to 0 minus 5. Or -6 is greater than or equal to -5. True or false? Well, -6 is not greater than or equal to -5. So that's actually false, which just reiterates that I should not be colored down here. So this is going to all be false. Any point I plug in down here will give me a false statement. Here are my trues, and I want my trues to go in to the shading. Okay, last thought here on the check. If you would pick a point right on the line, it would end up being true because we are equal to the line. So that's why we made it solid. The visual aspect of this being a solid line tells me that if I check a point on the line, it's going to make this true. So I'll show you that. Now, a point on the line, well, I could choose anything, but I'm going to choose the y-intercept, 0, -5, simply because I've got that 0 for the x, which is easy to work with. So if I come down here and check that guy, 0, -5, then plugging into here, I would have -5 is greater than or equal to 1/4 times 0 minus 5. And so -5 greater than or equal to 0 minus 5 gives me -5 greater than or equal to -5. Now, that's actually true. -5, it's not greater than -5, but it is equal to. So because of the equal to, this is true, And so the dots on the line should be connected with a solid line. Okay? Alrighty, let's go on to our next example. Now that's the only one I'm going to go through with the checks. You get the idea. That is how, if you were unsure, you would check yourself. Okay, so the rest of these examples will move along pretty quickly. Here's example 2. We're going to copy down y less than negative 2x plus 4. Again, slope-intercept form. So my slope is right here, negative 2, which I'm going to write as negative 2 over 1. And my b, or my y-intercept, is 0, 4. So I'm going to go ahead and plot 0, 4. Okay, 0, 1, 2, 3. Here's 0, 4. And I'm going to, from there, the launching point, come down 2 and right 1. And I can do that a lot of times here. I got plenty of room to keep coming down 2 and right 1. Can also go the opposite way, up 2, left 1. Now, I am going to connect those dots. Look at your symbol and look at our cheat sheet from earlier. If it doesn't have the equal to on it, it's dashed, because you are showing that although this is a boundary between the shading and the non-shading, that the points on this line or this boundary will not work. In other words, if you would put this point, any point here, you put it into here, it's going to be false. So we are discluding the points on the line. Okay. Now, put your pen or your pencil on the y-intercept 4. Put your pencil down there and decide. Look at your symbol here, less than. The y's are less. The y's are less. So would less be up or down? Well, I hope you're thinking that y gets less if you go down, less than, down the y. Y is less than. So I need to color that side of the line, which is down here. And there you have it. So all of your solutions to this inequality lie on this side of the boundary, not this side. Pick a point over here, put it in here, false. Pick a point here, put it in here, true. Pick a point right on, put it in here, false. That's why we are dash. That's the visual cue to not use these points. Okay, let's look at the next one. We have 2 to go, by the way. The next one, down here, example 3, you want to copy this down, 3x minus 2y less than or equal to 6. Notice we are in standard form. So there's 2 ways we can graph this. We can either grab the intercepts, the y-intercept and the x-intercept, which would be pretty easy to do since 6 is divisible by both negative 2 and 3. Or we could rearrange the furniture and put this into slope-intercept form. So why don't we do it both ways? If I find my y-intercept, then the x will be 0. And if x is 0, let me get rid of him, you'll have negative 2y is less than or equal to 6. So divide both sides by negative 2, and you're going to get negative 3. And if you do your x-intercept and you let your y be 0, if y is 0, this goes away, and 3x is basically equal to that 6, and divide by 3, and you get 2. So that's one way we could graph these 2 and connect the dots. The alternative is to solve for y and get this into slope-intercept form. So if I bring this over here and I minus 3x from both sides, These will cancel, and I'll have negative 2y is less than or equal to negative 3x plus 6. And when I divide everything by negative 2, I'm going to get y. Watch, I hope you remember this. When you divide by a negative in an inequality, the symbol flips. So y is greater than or equal to negative divided by negative is positive 3/2 x. 6 divided by negative 2 is negative 3. So I can either graph these or this. I want to show you that they're actually the same. So for this guy right here, my m is 3/2, and my y-intercept is negative 3. So I'm going to start at negative 3, which you can see right there, y-intercept 0, negative 3. I'm going to rise 3, 1, 2, 3, and run 2. Boom, right there's the x-intercept, 2, 0, 2, 3, 1, 2, 1, 2, 3, 1, 2. Can go the other way, 1, 2, 3, 1, 2. Now, look at your symbol, less than or equal to, or right here, greater than or equal to. That means the line will be solid line, and shading. Well, don't look at this one for shading. You got to look at this one, where the y is isolated. Y is greater than or equal to, greater. So put your pencil on the y-intercept. And where would y be getting greater? Up. So you got to shade up and color this side of the line. Greater than. Put your pencil here on the intercept, greater, y greater. It's not what x is doing, it's what the y is doing. And finally, last but not least, example 4, we are going to just do these two special cases yet. One horizontal line, one vertical line with some shading. So this one right here is your horizontal line at negative 3 on the y. So come down to y equals negative 3. You're going to draw a dashed horizontal line there because the symbol doesn't have the equal to on it. And you're going to shade greater than. So here's the y-intercept. Greater would be up the y is greater. So you color this side. Here are all the y values greater than negative 3. And on the flip side, here you have your vertical line at 5 on the x. So we'll go over to 5 on the x, and we will draw a solid vertical line. And we will shade where x is less than that, less than x. So put your pencil here. X less than would go that way. So if I was doing this vertical line, x less than, then I would color this side of my vertical line in red. Okay, so there are 4 examples of how to graph linear inequalities. And now we'll work on mastery of that. Thanks for watching.